Hello, John here again, and this is part 2 of the Neptune Lander tutorial, 33 I think, yep 33, and in the first part we just tried the basic mechanics and applying the physics engine to the lander, and we wrote this program. So if we start it, yeah, F5. You see the lander being built, and then it drops, and you can see it gets quicker and quicker and quicker and quicker. We also put left and right on it, but as you can see when I let's I'll let it go in too fast now. So let's F5 it again, see if we can keep it slow. But as you can see, as soon as I let go, let's like that. Slide back down again. There we go. As you can see, when I press left and right, I press it and it moves, and then when I stop, it stops. And that's not really right. And as you can see, when I press thrust, the ship stops, which is wrong. So in this video, we're going to take this a bit further. So I've created a new file. I'm going to copy this. I'm going to paste it into Neptune 2, and we're going to get rid of that one. Right. And what we're going to do is we're going to find out why when pressing T the ship just stops. And so here's T, so we apply thrust, and so we go to 210, which is applying Y to the sprite. Oh right, okay. The sprite, the Y modifier is here, so that's an issue. So we need to, right, we'll make that 14, and we'll make this 210. So let's F5 that. Now we should have a ship that doesn't pause. So here we go. So we'll let it fall. Right, I'm about to press T now. There you go, that's better. Let go. And it's fallen again, and I press T again for thrust, and it's going back up. So that's fixed that problem. But the other problem is that when pressing left and right, where it's instantly moving left and instantly moving right, and as soon as we let go of left and right, it stops moving left or right, and that's not good. And so we need to apply a little bit of inertia, and applying left and right inertia is just like applying gravity to vertical velocity. So what we're going to do is we're going to change this to, instead of velocity, we're going to change it to vertical velocity. So every V that we see, we're going to change it to vertical velocity, so VV. So let's just make sure we've got everything here. So whoops, undo. So vertical velocity, vertical velocity. So that should be all the V's. Yep. And we're going to create another one called horizontal velocity. We're going to initialize that to 0, and we're going to create another one which is horizontal inertia, and we're going to make that 1/8. So this is like the gravity variable, and this is like the vertical velocity. So instead of applying x directly here, we now, so for D is going to be left. We're going to make that go horizontal velocity equals horizontal velocity plus horizontal inertia. We'll get rid of the poke because we're not poking directly to the X register. So we'll do the same again. Horizontal velocity equals horizontal velocity minus horizontal inertia. And the up and down we're going to rem out because we're controlling the up and down now by the thrust. So what we need to do now is we need to have a modifier for x. So we can put it here. So x equals x plus horizontal velocity, and then AND it with 255. And then here we can poke 53248, x. Now that will allow us to have the inertia. So what I'm going to do is I'm going to rem the vertical velocity modifier so that the lunar lander stays still. So F5, and now we should have some sort of inertia on the lander. So there you go, the lander stood still. So if I press D, there you go, it speeds up. Now I'm pressing A and it's slowing down and it's gonna go the other way, and then if I let go of A it still goes. Press D, there we go, press A. So now we've now added inertia to the X plane, so it doesn't instantly go left, instantly go right, and then when we let go of the key it stops, because that was a bit silly. So if I bring back in vertical velocity and then F5, this should be lunar lander in essence. So he's dropping, now I'm pressing D, so he's going that way, and I'm pressing T to try and slow him down, and then I'm pressing A to stop him going off the page a lot, keeping hold of A, letting go of A, pressing T to make him go up, letting go of T, pressing D. Now I've just noticed something. D and A are going the wrong way round. See, D has the thruster coming out of that side, so it needs to go in the opposite direction. So if we turn them around and press F5, do it again. Right, so it's going to drop. So I'm pressing T now to slow him down and make him go up. Now I'm pressing A, which should push him. That's the way. Now I'm going to press D, and that should slow him down. I'm going to press T to right D, back on D, so it slows him down and makes him go in that way. There we go. So that's the basic mechanics of this lunar lander game. Now the problem is we've been guessing with these intervals. You know, we've been saying that it needs to, you know, it's 32 times before we, you know, has to run through 32 times before it applies the full gravity and the full thrust. Here we've got 8 8 times to apply the inertia, the horizontal inertia. So what I'm going to do now is we're going to find out how many times this goes through. So we're going to rem out the delay, so we're going to have no delay, and we need to find out how many times it runs through in a second, so we can have a bit more of understanding of the loop thing. So what we need is we need a circuit counter, we'll make that 0. So this is going to be the how many times we loop round the circuit, and then we need an initiator here. So we need to measure a second. So we're going to say st dollar, so stopwatch dollar equals ti dollar equals time. So this is saying that st dollar is equal to the current time at that moment. So we initialize the time, and then what we need to do is when we update the sprite here, we go cc equals cc plus 1, and what we need to do then is once that's done, we need to check the time before it goes back. So we need to go if st dollar is not equal to ti dollar, then end. And what's this? Because time on the Commodore 64 time, in fact, yeah, time. I mean, I can show you. Let's see if I can show you. We're gonna run this, but I'm not gonna actually run it. Yeah. So stop. Right. So what we're gonna do is print ti dollar, and as you can see, it's 9. So if I do it again, 14, 15, 16. 17, 8, 19. So it's measuring in seconds. And so what I'm doing here is saying if the time that we took up here is now different than the time itself, we're going to end. And this should give us, because we're adding the cycle counter, we should find out how many times it runs through this routine in 1 second. So here we go, F5. And we're going to just let it start up, and we're not going to do anything, we're just going to let it do it, and it'll drop out. There you go. And if I do print cc, 14. So this program in BASIC ran through this loop here 14 times a second. So now we've got a really good number we can work with. So if let's rem that out, and rem that out because we don't need it, and rem that out so we don't need that. So we now are understanding that this routine runs through every 14th of a second. So if we want it to drop 3 pixels in a second, we have to say 3 divided by 14. If we want this, then it's going to be 14 for that. And same with this, 14 for that. Right, so let's see how that affects the running of it. So F5. And we're just going to leave it alone. We're going to let it drop and see what it's like. Wow, that is fast. So 3 pixels every second is a bit too quick. So what we need to do, now we're working in 14s, is go, okay, 28. 28. 28. And F5. So we're just going to let it fall. That's better. That's better. I think that's quick enough. Slow it down. Let it go up. Let go of T. I'll let it fall down again. Pressing T. Let it go up. Let go T. There we go. Just goes off the screen, comes back. T again. Now I'm pressing A. There we go. Now I'm pressing D. Now the problem is, look, it's getting bigger, faster and faster and faster, and we don't really want that because it's got massive jumps, and we need to control that gap every time it cycles through the and so what we need to think is, right, okay, what's the terminal velocity of, so what's the fastest VV can be? So in every cycle, what's the fastest number? What's the biggest pixel jump that we can have per cycle count? So as a rough guess, if we say if VV is greater than, let's say, 3 pixels, then VV equals 3. So we're saying that as soon as vertical velocity gets bigger than 3 pixels, or 1 gravitational unit there, we're going to keep it at that. So that's terminal velocity. And we can also apply it for horizontal velocity if we wanted to. So, you know, but the problem is horizontal velocity is up there. So we'll forget horizontal velocity at the moment. We'll just apply it to the vertical velocity. So I've just added that there, which means that the lunar lander should speed up and then stay at a constant rate. So I'm just going to let it go down, let it run. Right, there we go. So that's the maximum speed we're looking at. So I'm pressing T, that speeds it up. Now we can have it going up as fast as possible, so we need to do it the other way as well. So that's 3. That's 3, right. So, but the problem is vertically it was having an issue as well. So what we need to do is another testing. If VV is less than -3, then VV is -3. So that means we've limited how fast it can rise and fall. So let it fall. There we go. It's not, raise it, and that's as quick. And that's as quick as it's going to be. Now, the problem with this is when you come to playing the game. Right, so we're just firing it up. F5. Yeah. When we come to play the game, is that drop there, that speed there, too fast? And it's still jumping as well. Still a pretty big jump, that is. Okay, let's say not 3, let's say 2. Right. F5. So let's see. So that's the fastest it's going to fall. I press T and it goes back up. Right, let's shall we compare this with the real thing? So, lunar lander, where are you? Lunar. Oh, it's not lunar, it's Jupiter. Yeah, Jupiter lander. Right. So we're watching it fall. You know, we're seeing how fast it will fall. That was 2. Every cycle was 2. But the problem with the thing with this, because it's written in machine code, it's going through more cycles per second, so it looks a lot smoother than it would do in basic. So that's a F1. Too late. So we'll let it go over. Let's see how fast it goes up. So that's going up by 2. So its maximum drop is 2. And maximum speed up, let's do it, here we go. Oh, I've run out of fuel. Okay, let's try again. So it drops, and it's dropping at 2. And that's going up at 2. Right. Now we've looked at that, we need to readjust this. So we've gone and said it's dropping at 2, maximum drop 2, but the thrust is not as powerful as what we've got here. So if we drop, if we do 3, that means it's going to counteract the gravity. But the thing is, we're bypassing gravity, so 3 should be okay. F5. So we're letting it drop, and now I'm applying thrust now, and that's slowed it down, that's speeded it up. Now I've let go, slowing it down, and it's, see, that's 2, that's dropping at 2. That's a lot faster. Have I forgotten the other one? If VV is less than -2, then VV equals 2. -2. VV equals 2. VV equals -2. We'll have to have a think about that. But I've also noticed something else. The Y value, when it's doing Y's, it's not doing the half values. It's really weird. So if we need to re-enable this print. We need to find out what's going on. So print, we'll send it to home, and I want to see Y value and the vertical value. 5. Because if you notice, the lunar line is dropping every time it's sped up. It's speeded up quickly, not in. Right, let's see. Let's have a look. Oh, did you see that? As soon as it gets less than 0, it's not updating the Y value. Ah. Okay. Now, why is that doing that? Why is that doing that? Oh, hang on. No. I'm wondering if it's this. Let's try that out. Yes. Right, I'm going to stop it. I'm going to do a little test. So I'm going to say print, and the equation is y plus whatever the vertical value is. So if we say y is 10 plus, no, plus, no, where's plus? Plus, there we go, plus vertical value. So if we say vertical value is 0.5, then that should be 10.5. There we go. But if we go, oh come on, insert 10 plus 0.5 and 255. Right. So we need to wipe out that. Ooh. That's interesting. That's interesting. So as soon as we AND it with 255, it converts it into an integer value. Really? Really? Let's have a look. Let's ask Google. Commodore basic and command. Right. And operator. Doesn't it give say what the result is? And performs two different functions. In Boolean expression, it be used in bitwise operation. Okay, bitwise operation. A bit in the resulting integer. Oh, right. Okay. So that's why we're getting that funny jump. So what's happening is it's not adding 0.5 to y and giving that smoothness. What it's doing, it's saying, right, as soon as I jump to the next whole value, that's when I'm starting to add. Right, so what we need to do, we need to get rid of these here. And do it here instead. So, bracket y and 255. X and 255. Maybe not. Maybe not. Gotta think this a bit. Gotta make this a bit more cleverer than that. So working X and Y out here. Okay, so if X is greater than 255, then X equals X and 255. If Y is greater than 255, then Y equals Y and 255. So that will result in an integer, but at least it's adding up using. So it's adding up using the normal ones until it gets to 255, and then we make sure it doesn't go higher than 255. Because if we make it go higher than 255, it will blow the poke. Okay, let's try that. F5. Let's see if that's a bit smoother. Keep my finger on T. So, ooh, what did I do wrong? 213. Oh. Do. F5. Right, let's smooth this over. Right, so we're letting it drop. So it's. Oh, that's much better. It's still going to. Right, so it stopped at 2. Yeah, we need to. That says 2.8. Don't believe that. Let's make that clear. Right, F5. Right, there we go. So that's the X and Y. So it's maxed out at 2, so I'm pressing the thrust now. So it's decreasing vertical velocity. But thrust is going up to 4, 5. Wow. So there's something wrong with this test here. If vertical velocity is greater than 2, then vertical velocity. Oh, hang on. Maybe it needs to be that way. F5. That can't be right. Okay. Let it drop down to the max. Ooh, bounce. Ho ho! Well, that didn't work, did it? So vertical velocity is less than -2, and the vertical velocity equals -2. F5. Why is it going up to 4? Right, so it drops down 2, so I'll press T, -1, -2, -3, oh dear. And even it blew this as well. Yeah, because you can't have a negative number, so we're going to have to, if y is greater than 255 or y is less than 0, we do that for x. X is, or x is less than 0. Okay, so y is vertical velocity, not sticking, but -2. If vertical velocity is less than -2, then vertical velocity equals -2. Very strange. F5. Let's do this again. So it's gone to 2 -1 -2. Well, that stopped the initial bug. Maybe I need this on a separate line. 201. Let's try that. F5. So it's dropping. It's maxed out at 2. T. So it's dropping. -1. Oh, it's still going bigger than -2. That's an interesting one. Very strange. Very strange. Well, I'll have to look in that. Anyway, that's 33 minutes on the clock here. So we've fine-tuned this basic program in terms of the gravity physics for this lunar lander program. And what we're going to do now is we're going to try and create some landscape and see if we can build out this program and take it from there. Eventually it will be converted into assembly, but it's best to do it in basic, because then you can understand the mechanics and the mathematics that you need to get used to and all that, just to make sure that your program's running right, and then we can assemblify it. So with that, I will say ta-ta for now, and I'll see you in the next video. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.